Hey, this screencast is about velocity time graphs. Alright, so we've already had a look at displacement time graphs where it's the position of the object which is on the vertical axis. But in this case with velocity time graphs, it's the velocity that is on the vertical axis. And notice that our units here are ms to the negative 1, and that's just another way of writing meters per second. So ms to the negative 1 is the same as meters per second. And we can also see that on the horizontal axis, once again it's time, and it's measured in seconds. Also notice that on our vertical axis we both have a positive scale and a negative scale. Now this, in the real world, this would translate to opposite directions. So in this case we might make the positive directions, we'll make them easterly. So a positive velocity is a velocity in the easterly direction, whereas a negative velocity would be in the opposite directions, which is west. And of course, that's what's important about velocity. Remember, velocity is not only, it's not speed, it's speed with the direction as well. And so if something was travelling at 4 meters per second in the easterly direction, well, it must be travelling east. If something was travelling in the westerly direction, in this example, it would have a negative velocity. Or the other way we'd say it might be 3 meters per second in the westerly direction. Anyway, let's get down to an example. So here's an example of a velocity graph. So let's just run through a few aspects of it first. Now, remember this is velocity, and so the graph, at this point here, the velocity of the object would be 0. Okay, that's actually 0. Now, as time moves on, after 1 second, you notice the velocity is increasing. So for section A, the velocity was actually increasing in the easterly direction. And of course, an increasing velocity implies that there is an acceleration. Now, in section B, you'll notice that once again the velocity is increasing, but it's increasing at an even greater rate than in section A. And so in section B, we can see there's also acceleration occurring, but it's even greater acceleration than section A. And what we can gather from that is that with a velocity time graph, the higher or the steeper the gradient, this is for a velocity time graph, the steeper the gradient, the greater the acceleration. Okay, let's have a look at section C. So section C, well, that's flat. And for that entire section, which is between the 4 and 5 second mark, so between the 4 second mark and the 5 second mark, the velocity maintained a value of 6 meters per second east. And so its velocity wasn't changing. And therefore in that section, the acceleration was 0. There is no acceleration because its velocity is not changing. Remember, the definition of acceleration is the rate of change of velocity over the change in time. If the velocity is not changing, if the change of velocity is 0, then by default, the acceleration must be 0. All right, now let's have a look at section D. In section D, the object, whatever's moving, its velocity is reducing. It's still travelling. This is the tricky part. If we got to the 7 second point, we can see that its velocity is approximately 2 meters per second east. So it's still travelling in the easterly direction, but it's not moving as quickly as it was at the 5 second mark. So its velocity is reducing, but it's still in the positive direction. If it keeps going, at the 8 second mark, at that instant, at 8 seconds, the velocity is at 0. And so if the velocity is zero, if velocity equals zero, what does that imply? Well, that implies that it's at rest. It's not moving. So that implies it's at rest for that instant. Now you can see in this graph, if we can now continue, that it was at rest for a split second, for just an instant, and then it continued into section E. Now let's have a look at section E. In section E, we can see that it's now after, let's see, at the 8-second mark was 0, and at the 9-second mark, it's moving at 4 or negative 4 meters per second, or 4 meters per second in the westerly direction. And so its speed is increasing, but it's increasing in the westerly direction. So what's actually happened in section D and E is that here it was slowing down, stopped, and now started moving and speeding up in the opposite direction. In section F, we can see now that it's maintaining a constant velocity of negative 4 meters per second, or 4 meters per second in the westerly direction, until finally section G, it now starts to slow down. Remember, it was traveling in the westerly direction. It's slowing down, and after 13 seconds, it has returned to rest. Its velocity is 0. So that's a brief description of what's going on with this journey. In our next video, we'll actually look at doing a few calculations based on this graph. Thank you.